Or a video for the 2017 SAC. So, all right, so it's calculator allowed, so you can use a calculator, but please choose wisely whether you want to use a calculator or not, because some questions you don't really need a calculator. So, for example, first question, g of x, we've got a hyperbola. It has an asymptote at 3 and -2, and a y-intercept at -5. So automatically, I already know that g of x would equal, we don't know our a value. We'll know that the vertical asymptote's at 3, so that must be -3. And the c value must be -2, exactly what you expect. So opposite of what you expect, exactly what you expect. And all I need to do is solve for a. And we know the y-intercept at 0, -5. Okay, so I'm going to go pop on my main screen. And I am going to sub in what I don't know, what I do know. So I'm going to go -5. When y is -5, x equals to 0. So I'm just going to use x instead of a. X divided by -3 minus 2. Okay, so interactive and solve. And solve. For a, essentially, a equals 9. So your final equation would be g of x equals 9, x minus 3, minus 2. Done. Okay, so a equals 9 when you solve it. State the domain and range of G. Okay, so the domain would be, well, the graph has moved 3 to the right and 2 down. So my domain, my vertical asymptote's at 3. So when you draw the graph, it could be any value except x equals 3. So it means reals excluding 3. And my range would be everything excluding -2. So y equals -2, there's an asymptote there. So range everything except -2. Right, so state g of 1. G of 1 would be when you sub in 1's equation, so 9 divided by 1 minus 3 minus 2. So it's g of 1 is -6.5. Or -13 on 2. Okay. X such that g of x equals 0. So you're going to let g of x equals to 0. So you're letting the whole equation equal 0. So I'm going to go 9 x minus 2. X minus 3, sorry. Minus 2 equals 0. Interactive and solve. So essentially, you're trying to find x-intercept. Or x-intercept. X equals 7.5. Okay. 7.5 or 15 over 2. Okay, you're done. Next question. So a Ferris wheel local feet is shown. They've given you a model. Okay, so it's a circular model. The center is located at 0, 5. So state the rule. Now the x hasn't moved anywhere, so it remains x squared. The y's moved up 5. Okay, so it's y minus 5 equals r. Let's see what my r is. So the center and the lowest carriage is 1 meter off the ground. Okay, so this is 0, 1. And we know this is 0, 5, so it must mean the radius is 4. So r squared, 4 squared is 16. Right, state the domain and range. Well, if the radius is 4, that's 0, 9. If I go left, I'm at 4, 5. If I go right, I'm at -4, 5. -4, 5. So the domain would be between -4 and 4, and the range would be 1 to 9, including. Okay. So is this a relational function? So it's a relation because for every x value, there isn't just one unique y value. So don't say vertical line test because that's not a valid reason y value. Okay, so you must state the actual reason. So don't say, oh, the vertical line test fails the vertical line test. It does fail the vertical line test, but that's not the reason why it's a relation. Okay, so not a function, not a function. Okay, question 3. We've got an artist's impression of a graph. Okay, and we want to sketch. So we state the domain and range of both A and B. A would be between, okay, it's hard to read, that's -5, and that's 4, I believe. Okay, so it'll be -5 to 0 for A. The range would be from 0 to 4. Okay, the B of X, the domain is -5. Now, notice there's an open circle there, so it doesn't include 0, so it has to be closed circle. Not closed circle, but round bracket. The range would be from, that's -2 to 0. Well, not including -2, -2 to 0, including 0. Okay, so you've got to be really careful with your brackets. If A and B, state if A and B are one-to-one functions, so AX and BX, so A would be not a one-to-one function because it fails the horizontal line test, so not one-to-one, and B would be one-to-one. Draw the inverse of each. Now, for B of X, we'll do B of X because it's easier. I know that the x-intercept's -5, so the y-intercept will be at -5, and the um, x, the y-intercept's at -2 originally, so the x-intercept would now be at -2. Okay, and there's an open circle here, so make sure you copy exactly what it has. So that's the inverse. Which makes sense because it reflects along the line y equals x. Okay, so you should get what that looks like. And then for the quadratic, you've got a turning point at 0, or -3, 0. -3, 0. So it's going to look, so it's going to have a y turning point at -3. So -3 somewhere here. Okay, so that's y turning point. I'm going to have an endpoint at 4 on the x-axis. So I'm going to have endpoint of 4 on the x-axis. And also, what do I know? I also know that the endpoint here is -5, 4. So if I flip it around, that's 4, -5. So 4, -5 is somewhere here. Okay, so it's going to look something like this. It's going to look something like this. Okay, so that's -3, and that's 4, -5. Okay, so you do have to label your points. This you don't need to label because I know where it is. Okay, so shape is important, and detail like those is really key to. Okay, so I've done that. Next part, so we've got a map coastline using quadratic function. We got 3 coordinates, and we want to find the rule. Okay, so there's more than one way to do it. Now the trick is I always try to take the shortcut wherever possible. I'm going to use this spreadsheet because it's easier if you can pull it off. If it doesn't give you exact answers, then okay, you have to use functions. 60, -40, 20. Okay, so I'm going to go calc, regression, quadratic regression. Okay, as you can see, no, we can't get away with cheating. You have to sub in a model. Okay, so remember the most basic model for 3 points would be f of x equals ax squared plus bx plus c. Okay, so I'm going to just bite the bullet and go a x squared plus bx plus c. bx plus c. I'm going to define it. Okay, f of x, great. Now I can use the simultaneous tool. So I'm just going to go 1, 2. F of 40 equals 40. F of negative 10 equals 60. F of negative 40 equals 20. And then you go so on for A, B, C. Okay, and we don't want decimal because the purpose of doing this is so you can get exact answers. Great. I've got all my coordinates. So my A is negative 13 on 600, B is a quarter, C is 194 on 3. Done. Okay. Now, if it asks you to write the equation, you obviously will write it like this. So m of x, it doesn't ask you in this case, squared plus a quarter x plus 194 on 3. You're done. Okay, question 5. So the temperature inside the oven is modeled by the over 5 minutes shown on this graph. What is the temperature after 2 minutes? Okay, so you've got to form a linear equation because we know that's 0, 0, and that's 200. Okay, so we need to form a linear equation. So m equals 200 minus 0 divided by 2 minus 0. So that's 100. Okay, so essentially the equation would be, well, it's in terms of t, small t and big T. So instead of y equals m plus c, we go t equals mt plus c, like that. Okay, so I want to sub in a point, I'll sub in 0, 0. Okay, so when t equals 0, small t equals 0 as well, so c equals 0. So your equation for t would be m, which is 100, t, like that. So big T is 100 T. So what is the temperature after 2 minutes? Oh, we didn't even need to do that. We can just go 2 minutes. Oh, what's the temperature after 2 minutes? 2 minutes is 200 degrees Celsius. Using interval notation, state the temperature is equal to 200 degrees. Okay, so it's 200 degrees along over here, meaning T is an element of 2 to 5. Okay, so at 2 and 5, that's where the temperature is 200 degrees. Okay, the temperature can be represented by a hybrid or piecemeal function. What do T and T stand for? So T stands for temperature in degrees Celsius, and T is so it's the temperature of oven. So you gotta be specific, of oven, and T is time passed in minutes of oven. Okay, so we define it, and we want to find T of 1. Okay, so T of 1 would be very simple because I've already figured out the Lie equation. T of 1 would equal 100 times 1. Okay, so it would be just 100 degrees Celsius. Okay, so we need to complete the table. Now we've already found the first equation. I know that A is 100. Now B is 0. Okay, because the C value is 0. And then E is just a straight line, a horizontal line. So we know that it's just equal to number, and that number happens to be 200 because it stays at 200 for a while. Okay, and D, hang on, I think I've jumped the gun here. I haven't finished yet. C is the starting point. The starting point's at 0, and then it goes to D, which is 2. Okay, so that must be 2 because interval in which this linear is valid is between 0 to 2. Okay, so that's why C is 0 and D is 2. E would be 200. Okay, that's F would be, okay, where's E starting? E starting at 2 and ending at G, which is 5 minutes. Now H um, H starts after 5. Okay, so that's H starts after 5. So we're done. Okay, pretty straightforward. So I like this question because it really tests your understanding of like hybrid functions really well. All right. Next question. Sketch the graph of this. Okay, so our turning point, it's in turning point form. Our turning point's at 2, -4. So 2, -4 is here. It's a smiley face, so 2, -4, smiley face. Let's find the x-intercept. Now you can obviously use a calculator to this. So x-intercept y equals 0, or f of x equals 0, x minus 2 squared minus 4. I'm going to go equals 0, interactive and solve. Interactive advanced solve. Okay, 0 and 4. So 0 and 4. So that's where they intersect. So I can pretty much draw the equation. So it looks like something like this. Okay, it goes on forever. Okay, maybe not like that, but like this. Now, what do I want to state? Domain. The domain would be all reals, because there's no restriction on it. The range would be -4 to infinity, because that's the lowest value. Not -4 to 0, -4 to infinity, because that's, and you don't include infinity, because you're going from the lowest value is -4 to infinity. Okay. Is f a one-to-one function? Explain. No, because while it passes vertical line test, you can talk about the vertical line test, but explain what it actually means. Line test, i.e., has unique y values, has a unique y value for every x value, so it has a unique y value for every x value. It does not pass horizontal line test. So what does a horizontal line test? There isn't a unique x value for each y value. I'll go even further and go, for example, for the y value of 0. So for the y value of 0, if I look at the y value of 0, if I do a horizontal line test, you have two possible x values of 0 and 4. Okay, so as you can see, we highlighted that for the y value of 0, the graph intersects twice in the x. So you got x values of 0 and 4. Okay, so something like that. Let g of x be, okay, state the maximal domain such that g has an inverse function. Okay, now if you think about this very carefully, we want an inverse function. Okay, inverse function, meaning that the function or the inverse has to pass the vertical line test. Now, if I were to get the inverse of the whole graph, what I get would be a graph that looks like that. It will be a parabola on the side. Okay, so the problem with that is it's not going to pass the vertical line test. Okay, so in order to make this graph have an inverse function, we're going to split it into two. We're going to split it in half, because if I have this half and I reflect it, it's going to still be a one-to-one function. Okay, likewise, if I have this function and I split it in half, not split in half, if I find the inverse of it, then it'll still have it'll still pass the vertical line test for both of them. Okay, so state the maximum data such that this has an inverse function. Now you can do it two ways. Okay, you can split it you can want the first half or you can get the second half. It's up to you. Okay, it's totally up to you. So I might get the second half. So 2 to infinity. So your domain 2 to infinity. Okay, 2 to infinity will be a good domain. Now there's two answers. Obviously, you can have uh, negative infinity to 2 as an answer. So use the domain state and to find the rule for g neg 1x. Okay, so g neg 1x. So if well, you have a calculator, right? You can switch the x and the y's. Okay, so I'm going to switch the x and the y's. X equals 2, y minus 2 squared minus 4. And I'm going to solve for y. Okay, I'm going to make y subject, essentially. Command solve for y. Okay, and I get two solutions. Now, which one do we want? Think about this for a second. Okay, so if you look at the graph, if I'm using this half, okay, the line y equals x looks like is along here. So if I reflect it, it's going to look something like, something like this. So we'll start at 4, negative 2, negative 4, 2, negative 4, 2 would be somewhere here. And, you'll get a graph looking like that. Okay, it'll just be a mirror image of your original graph. Okay, so using states, the rule for the inverse. So if the graph looks like this, okay, if the graph looks like something like that, then it'll be the positive version um, of the original graph. So let's go down there. So g neg 1x would equal root x plus 4, x plus 4 plus 2. Okay. Now sketch both g and g inverse on the same axis. Okay, so hang on, let's label my g and g inverse. So my g would be from starting at 2, negative 4 to negative 4 here, and we have an intercept at 4, so it looks something like this. That's my g. My g inverse would start at negative 4, 2, because it flips. Negative 4, 2. Always label your points. Negative 4, 2, and it will have intercept at 4 as well. Okay, so have intercept 4 like this. Okay, yep. Okay, so it looks something like this. So negative 4, 2. Yep, that's okay. It looks something like that. Now, the reason why it looks slightly wonky is because the scale is a bit different. Okay, the scale is a bit different because if you were to draw the original and the inverse on the same graph, so let's just say I want to draw the original. Let's go back to the original. So go x minus 2 squared minus 4, and you were to draw this graph. Okay, and you wanted to sketch the inverse. Okay, as you can see, the inverse would be inverse for our section, which is this section, would correspond to here. Okay, correspond to here. Okay, so it will look something like that. Okay, but because the scale is nice and even, our scale's not even, we're not going to get the same sort of shape. Okay, so just bear that in mind when drawing it. Okay. Question 7. So you got a rectangle with a perimeter of 100. Let x represent the width. Write expression for the length in terms of x. Okay, so that's x, that's x. Now we've got 100 in total. So if I used up 2x already, then the lengths must make up 100 minus 2x. If I divide by 2, that will be each of the lengths. So that will be 50 minus x, 50 minus x. So the length would be 50 minus x. Right expression for the area would be x by 50 minus x. Sketch the graph. of area against width, so pretty straightforward. I'll just get rid of my graph. So I want x, oops, get rid of this, x 50 minus x. Now make sure you press X button from the calculator, like this, x50 minus x. So I'm going to draw this. Now I should know that my graph is not going to appear straight away because my x-intercept's going to be at 50, 0 and 50. So I might want to adjust my scale. Y, you might want to try 100, and X, you might want to try 100 as well, just to see if it shows properly. Okay, almost. My Y is not high enough, so go check your Y, 500. Let's see if it helps. Okay, perfect. It actually shows. All right. So I want to draw the graph. So I need my x-intercepts. Should be 0 to 50. I already know it already. Just looking at the equation. But if you're not sure, by all means use it. Okay, so 0 to 50, and my maximum is at 25, 6, 25. Okay, 25, 6, 25. So your graph is going to look something like this. So this is area, this is the x. Okay, so you're going to have something like this, 0, 50, and that's 25, 6 to 5. Just label all the coordinates. Okay, let's take the domain of A, and obviously you're going to use the ruler for this. Domain of A is an element of 0 to 50, including. Done. State the maximum area and its corresponding dimensions. Okay, so dimensions means the length and the width. So the area max would be 625 centimeters squared. Okay, and dimensions, the length would be 50 minus 25, because it's 50 minus x, and the maximum area occurs when the x is 25, so that's 25 centimeters, and the width would be x, so that's just 25 centimeters. So 25 centimeters by 25 centimeters. So you must include both the length and the width to get all the marks. So hopefully that gives you an idea of how to do that this type of SAC. So it's pretty straightforward if you know what you're doing. I think the tricky part is drawing inverses and knowing your points. But obviously, if you get the coordinates right, I'm more than happy to give you the marks. Okay, but like I said, in this case, um, in terms of grids, yeah, the graph's not very good because it doesn't show the inverse nicely. But other than that, the rest should be fine.